Now in this video, we're going to answer the following question. Find the greatest value of the following function. And we've been given the function f of x equal to 3 plus 2x minus x squared. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. In calculus, differentiation is the process of finding the derivative of a function. The derivative of a function represents the instantaneous rate of change at any given point. For the graph of a function, the derivative at a specific point on the curve is the slope of the tangent line to the curve at that point. For the maximum point of a function, the slope of the curve is a horizontal line whose gradient is equal to 0. In other words, the first derivative of the function at that point is equal to 0. The second derivative describes the nature of the point. For a maximum point, the second derivative has a negative value. Answering this question is a 4-step process. First, we need to differentiate the function to find the first, then second derivative. Before setting the first derivative equal to 0, to find the x value of the maximum point. Substituting that x value into the second derivative confirms that the point is a maximum, before substituting that value into the function f of x to find the corresponding y value of that point. To find the derivative of a function, we need to differentiate it using the power rule, one term at a time. The power rule tells us that if f of x is equal to x to the power of n, where n is any real number, its derivative f prime x is equal to n multiplied by x to the power of n minus 1. In other words, we multiply the original power by the coefficient of x and reduce the exponent of x by 1. For a function with multiple terms, we differentiate each term separately. So let's begin with the 3 term. Differentiating a constant term effectively eliminates that term. So 3 becomes 0. To differentiate the 2x term, we multiply the coefficient 2 by the exponent of x which is 1, and decrease the exponent, which is 1, by 1 to become 0, which gives us the term 2. Finally, to differentiate the minus x squared term, we multiply the coefficient of x, which is minus 1, by the exponent of x, which is 2, and decrease the exponent, which is 2, by 1 to become 1, which gives us the term minus 2x. For more explanation about how to differentiate the terms of an expression using the power rule, search our channel for differentiation. So f prime of x, the first derivative of the function f of x, is equal to 2 minus 2x. To find the value of the x-coordinate for the stationary point of this function, we need to equate f prime of x to 0 and solve for x. If 2 minus 2x is equal to 0, then subtracting 2 from each side gives us minus 2x equal to minus 2, which, by dividing both sides by minus 2, gives us a value of x equal to 1. To answer this question, we need to find the value of the corresponding y-coordinate. But before we do that, we need to check that this point is indeed a maximum point. To do that, we need to find the second differential of f of x. To find the second differential, much like we did with the first, we differentiate each term again using the power rule. The first term is the constant 2, which differentiates to 0. And the second term is minus 2x, which differentiates to minus 2. So, f double prime of x, the second derivative of the function f of x, is equal to minus 2. When f double prime is less than 0, the value of x represents a maximum point, which confirms that the x-coordinate of 1 represents a maximum point for the function f of x. When x is equal to 1, we can find the value of y by substituting 1 for x into the function f of x. And f of 1 is equal to 3 plus 2 multiplied by 1 minus 1 squared, which is equal to 3 plus 2 minus 1, which is equal to 4. So, the greatest value of the function given to us in the question, and the answer to this question is 4. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.